of species is happening faster than it has almost ever. Well, yeah, probably ever. Which is an interesting thing. Go ahead, Ryan.
Can I do the next one?
Yeah, sure.
Wait.
You have a question? Go ahead, Michael.
If I don't think humans, because we're consuming more, I don't think that's the fastest extinction ever. Because if we look at the thing that killed the dinosaurs, a meteor, that would have been a much quicker event, killing out thousands more. Also, there were things that survived something like that extinction. Animals adapting. Animals will adapt to overcome this extinction some way or another. So,
well, I mean, if they go extinct, if we change their habitat so fast that they don't have time to adapt, they're going to go extinct, and they are going extinct. The event that killed the dinosaurs, if you're referring to the asteroid, so definitely in the immediate area, that asteroid killed everything, right? And probably caused some extinctions in that localized area. But it took a long time for that asteroid to change, like the temperature of the Earth and stuff like that, to cause everything else to become extinct. Extinction today is happening faster than it even than it did back then. So,
all right, but if we still look at the example of the dinosaurs,
yeah,
we wouldn't be here on the Earth if everything would be wiped out by the asteroid. So by this extinction, even if it's to a greater scale, animals will still survive. So I don't think it's the end of the Earth or whatever.
Oh, I'm not saying that it's, yeah, we're not saying that it's the end of the Earth, but we're losing biodiversity. And that's something that we're kind of concerned with, is losing that biodiversity. Go ahead, Arma.
The bottom one.
Nothing I have concept or interest in participating in the human act as remembered. Very funny, you guys are humorous. Go ahead.
So, with the dinosaurs, that killed the dinosaurs, marine animals are relatively safe-ish, as things like megalodons possibly survive. But with things like climate change, species in oil are dying out very fast.
Yeah.
And that eliminates the possibility that aquatic animals can evolve into land animals.
Sure. I mean, the dinosaurs are a super interesting example of a lot of interesting things happening. Yeah. Good. Okay, let's keep going. A few more of these, and then we'll get started with what we're gonna do today. The more humans on the planet, the more resources we use, and the less habitat and natural resources we have. For example, if the amount of humans reached their max capacity, they would use a lot of resources. Yeah, and so we talked about, what's the population of the Earth right now? The human population of the Earth right now? 7.7 billion people. 7.7 billion. Yeah. Yes, question? All right. Go ahead, read that one.
We were warning about ocean population and its effects on the world. It had a negative effect on the world, for example, the pit frogs, WH.
Oh, so you didn't finish.
Which?
Argon.
Which? 7.5
Which
billion.
habitat got negative? Which was lost by humans.
7.5%. 27.
Yeah, so it's even higher now. I think it's 7.7 billion people.
Oh, wait, let's read the one with the cloud.
I do not wish to explain my thinking. However, I do not wish to regurgitate the info that has been fed to me.
Cowboy, clown.
Okay.
Cowboy.
Okay, so let's take a real quick look. In the first period, we looked at this website that kind of has some cool statistics. So give me just a second. I want to bring that up and show it to you, and then we'll move on with what we're doing in class today. Okay? Just a second.
Oh, I know somebody fixed that.
Is there beta? I'm not even. No, but I original school. Shook my stuff. Literally barely and stuff.
So he moved.
Choked
No,
me
I'm
from
on.
joy, and I wanted to die. And literally that day I got an extension. I was so mad. I was like, you know, I'm doing this extension right now. The day that I got the first one, I put in an extension. I am so mad. Rate it. Give me it. I deserve it. I know what I'm talking about. I literally did an entire poster to get like 2 points high. Give me like a 95. I like your shoes.
Okay, guys, hey, your attention up here. Guys, let's try that again. Your attention up here. Okay, so this is an interesting website to kind of check out every so often. This is world meters, and it just kind of gives us a measurement of some interesting things. So it has the current world population. You know, this is, you know, I don't know how accurate it is, but it's about 7.7 billion people, which is what we thought it
So
should be.
my technicality, I was right because I said 7.6.
Okay. Okay, it also has like the births this year, the deaths this year. Okay, the net population growth. So what is that? 25 million people are growing this year. That's what that is. So the net population growth today, 99,000 people. The day's just started. So, okay. Then it has things like these different categories like government and economics. Who cares about that?
I care about it.
Okay. Some other things.
Google searches today.
Yeah, money spent on video games. That's pretty high. Internet users in the world. This is kind of interesting. So the internet, 4 billion people are connected to the internet.
That's big.
That's it?
It's just a little. It's like 60%. But let's look at some of the environmental things.
How many animals are in the world? You know that?
I don't know. It
So
shows.
at least 7.1.
I don't think it's.
Okay. So we have a few things here. So we have forest loss this year. Okay, we've got land lost to soil erosion. You know, CO2 emissions, desertification. This is kind of interesting. We look at food. We talked about this. So we have undernourished people in the world. You know, about 800 million.
Mr. Richards,
Yeah.
it says people who died of hunger. So
Yeah.
why do they count the people, but they don't give them food?
So these numbers are probably estimates,
13,000 people.
and they're probably based on some like mathematical, represent.
Oh, yeah.
How can they document that?
2 more. 3 more.
Just gotta feed the hungry people.
Yeah.
And it's like,
Okay, so this is the one. In order to kind of make a connection to what we did and where we're going, this is what I wanted to look at. So the energy that we use, this is in milliwatts or megawatt, probably megawatts. This is the energy that we use. This is how much solar energy is striking the Earth, which is like, man, if we could tap into that a little bit more, better solar cells, less, like solar panels that are manufactured better. We could tap into this energy resource. That would be great. But we also have oil. I thought this was interesting. This is days until the end of oil, so we only have 44 years until all the oil is gone off the planet. That's kind of crazy. That's interesting. What are we gonna do in this time?
Make it at 22.
Oh, that's gonna be cool.
Hey, let's give ourselves a challenge. Make it
going to talk about today is we're going to start talking about waves, okay? And how we can use, we're going to talk about waves and how they're related to energy, okay? And we're going to look at that and we're going to try to like figure out how we could use waves to maybe create an alternate energy source, okay? So that we can like, you know, that we don't have to be relying on oil so much, and we could take, you know, more advantage of these renewable energy sources, okay? Good. Oh yeah, let me just switch my PowerPoint.
Yeah, so if you die, this one's cool. All like
No, why don't you? Oh yeah, I did. And I was like, wait, what? I didn't remember it. I was like, yeah, she was like, she probably had a similar feeling. I did like all of it. Honestly, I'm not even wrong. Like I did not study like beforehand, and I studied like, you know how we had ELT first at the end. Oh yeah. I used to close it for like 2 hours and study it. Because it's so helpful. The environment question.
wait, so oh, I bet you that.
Yeah, like when you're like, I thought I was just like stupid and read the wrong thing. I was like, wait a minute. Who are you?
Yeah, rub it on me, will ya? Oh. Oh, dude, I'm still pulling all over.
And I don't need to button my business. It's like,
That's racist.
That was like really just getting over it because I was suggesting that Aiden did. Like he was just like
Okay guys, hey. So I know you're excited about being back from spring break. You haven't seen each other in a while. Well, let's keep the talking down. Well, it's okay when I'm doing stuff. But
Are you
when
gonna
I guys,
edit this out for your video?
what's that?
Are you gonna edit this out for your video?
Yeah, I'm gonna do lots of videos.
I can edit for you. I'm really sure.
Yeah, yes. I couldn't edit
Okay.
this video.
Guys, so we're learning about waves. Okay, so what do you guys already know about waves?
Water. Moon.
Okay, so water affects waves. Neap tides. Yeah, we learned about how the moon affects waves. Or tides, not waves, but tides. Okay, what else?
It's a form of kinetic energy.
Yes.
Whoa, nice. Okay, hold on to that thought. We're gonna get back to that. Very good. What else? Are there different kinds of waves? Give me some different kinds of waves. Give me one, Michael.
Alright, sound waves.
Sound waves.
Wait.
Sonic wave.
Sonic waves, which are sound waves.
I know.
Okay, what else? Andy.
Gravitational waves.
Gravitational waves. Yep, we just discovered those. Very good. What else?
Water waves.
So water
Oh my
waves.
God.
Good. Like at the beach. What other kind of waves are there? Go ahead.
Heat waves.
Heat waves, like in weather. Microwaves. Those are a type of energy wave. So very good. A heat wave. I don't know. A heat wave might be a wave there could be a wave nature in that, but I think it's more of like, I think heat waves are more of like an optical illusion, and then also like more of like a weather factor thing. But microwaves are definitely a type of wave. Go ahead.
Long transverse surface and longitudinal. Longitudinal.
Okay, those are different types of waves. Go ahead. Yeah, radiation is definitely a type of wave. Kira? So magnetic waves?
Solar waves.
Yeah, sure. Magnetic waves.
Solar waves.
Go ahead. Sound waves was said. Yep. So when I'm talking right now, my voice is I'm creating sound waves that travel through the air and you pick up in your ear. Okay. Solar waves. So UV rays are or light travels in waves. Go ahead.
Light.
So I just said sorry. Light.
Hair.
Very good. Okay. Yes.
Like satellite waves, like communication waves.
Communication waves. We can use different energy waves in order to communicate. Great.
Wait. Radio waves.
Radio waves. Very good.
Ew,
Okay.
magnetic waves.
So our learning goals for this unit, or this task rather, is we're going to explore how waves have certain characteristics. We're going to learn about the characteristics of waves. Guys, pay attention up here. Thank you. So we're going to learn about the different characteristics of waves and how their characteristics relate to their energy. Okay? So we're going to explore water waves first. That's what the bins are on your table. We're going to play around with those in just a minute. Well, just a few minutes. And so we're going to identify characteristics of those waves, and we're going to kind of like formulate a definition. Okay? And then we probably won't get to this today, but we're going to use a computer simulation to kind of play with, the different characteristics of waves and see how they relate to energy. Okay? We're going to create a model of a wave that you're going to do and compare different amplitudes. And we'll learn about, some of these terms in just a minute. We're going to analyze characteristics of sound waves. So we're going to first start with water waves, and then we're going to talk about sound waves. And we're going to use an app. So like in your groups, one person at your table will have to download this app, and it's an oscilloscope. Am I saying that?
All right, I'll get it.
And it's used to measure different sound waves.
Wait, I just have one question.
Yeah.
Is it on Apple? Is it on Apple devices and Android or something else?
I'm not sure. Hey guys, focus. Okay. I had to give out several quiet lunches in first period. People talking too much. I don't want to do that. Okay, apply knowledge of waves and energy and explain the potential alternative energy sources. So the idea is we're going to learn about waves and we're going to learn how we could use waves as an alternative energy source. Okay? Oh, do you have the app?
I just got it.
Nice.
How did it download so quickly?
Okay,
It's a small
so
app.
just like we do, we'll get to the app in a little bit. We don't need the app probably until Thursday. Okay? So let's get through some vocabulary. Some of this may be familiar. So water wave, where do we see these? Give me some examples of water waves.
The land. Water.
Okay? Give me an example. Like
Well, the waves in the water are because of the moon creating tides, and since I was in Cabo, I got to go to a sandy beach with huge waves, getting up to 12 feet.
whoa,
Yeah, you couldn't see the beach.
that's cool. So we have waves in the beach.
Also, something that was kind of cool is the actual wave is not the part. Can you go back a couple slides?
Sure, let's go back. This slide?
Yeah.
Yeah.
This is right now the wave breaking, not the actual wave.
Right.
The actual wave looks something more
It's under the water.
like this, where I don't know if you can see this, but it's more just kind of a bump in the water.
Right. Good. Okay, and we can learn about how those form. Yes, go ahead.
You see water waves whenever you like poke the water.
That's really cool.
Yeah, when you create ripples in the water, like if you just touch water or throw like pebbles into a pond, those ripples are waves, right? Good. Okay. Okay, so the amplitude of waves. So this word amplitude, when we measure the amplitude of waves,
Isn't it how big the wave is?
it's how big the wave is. It's a measurement of how big the wave is. And so right here in this picture, we have like this black line would be, if there was no energy in the wave, we would have this flat line right here. Okay? But there's, something happens, a rock falls into the water, or, wind pushes water and creates, puts energy into the system, and it creates a wave. And so the amplitude is measured by, where the wave would be at rest to where it is to the peak, or at the bottom of the trough. So this is called the peak of the wave, is the high point of the wave, and the trough is the low point of the wave. Okay, and the amplitude is a measurement from, the origin, or where it would be with no energy, to where it is at the peak, or vice versa at the trough. Okay, so that's amplitude. Any question about amplitude? Go ahead.
On this app, it says the amplitude right now is negative. What does that mean?
The amplitude is negative?
Amp equals negative, right now, 30 dB.
So what that's probably doing is it's probably, I haven't looked at that app that you're using yet, but you're kind of ahead. So what it's probably doing is it's probably not picking up very, very small sounds. And so it's an adjustment that you can make so that you can ignore very, very small sounds. That's just a guess, really. But, okay, so let's look at wavelength. Okay, so here we have an example of wavelength. Or, sorry, no. Up here we have an example. Okay, so wavelength is the measurement of the wave. Okay, so it's the measurement from, either like the bottom of the trough to the next trough, or the top of the peak to the next peak. Okay, those are wavelengths. Okay, and just like you can have different sizes of wavelengths. Okay, that give your wave different characteristics. Okay, frequency is the amount of waves in a space of time. So if we have here, we have low frequency, where we have maybe, what is this, like, maybe 1.5 waves there. Okay, whereas here we have high frequency, the black line would represent like our time. And so here we have, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have, 10 waves in the same amount of time. So frequency is how many waves per time. Okay. Okay, and I think so. Energy. What is energy? Energy is the force that is able to do work. And we'll get into how energy relates to this vocabulary in just a little bit. I want to give you guys time to kind of play with the waves in order to interact with it. We'll talk about that in a little bit. Okay, how does matter and molecules, how do they factor into when we're talking about waves? What is matter and molecules, and why are they important when we're talking about waves? What do you guys think? Lawrence, go ahead.
Well, if there's like a higher frequency, doesn't like the molecules move faster?
Okay, if we have a higher frequency, the molecules move faster. Good. Good. We can build on that. That's a good thing. What else? What do you guys think? How else does matter and molecules affect waves? Go ahead. Maybe molecules make up the waves. So very good. Waves have to travel through something, right? Unless they're like, I guess, so light waves kind of are a little bit different. They can move in a vacuum, but like, you know, other waves, like water waves, have to travel through water. And so there's water molecules that the wave travels through. Okay, good. Mike.
So say right now if I'm talking, if I talk really loud, the room below us could hear us. So if, well, sound waves travel through air, and if
Yep.
they're, I guess, high frequency could travel through, or,
Certain frequencies can travel through
yeah.
certain substances, okay? Depends on how dense those substances are.
Yeah.
But yeah, so you were talking about sound waves. Sound waves travel through the particles or the molecules of the different matter in the air. Okay? Did I say what you were going to say, Ryan?
Dang it.
I'm sorry. Go ahead,
Well,
Zach.
Sound waves, like, do they move through the molecules or do they just move around the molecules?
So, do they move through the molecules or do they move
Like, not move around, but like move the molecules back. So, like, kind of a chain reaction of the molecules, like one
Yeah, so you're right. We do create, the way waves work is they kind of, they make what you were saying is like a chain reaction.
bump each other around.
They bump each other around. We'll get into more of that in the lesson, but that's a good observation. Good. Kira.
Just for the record, for optimal sound coverage, you want lower density and a higher frequency.
For optimum sound coverage, what does that mean? Explain that to me.
The farther and louder you want your sound to be.
Okay. You want, so say it again, sorry.
Like, the farther you want the sound to go and how loud you want it to be heard, you want it to be a high frequency and not very dense objects in the way.
A high frequency and not very dense objects in the way. Okay? Interesting. So how would that relate to energy?
Anything in the way of it can, the higher the density, the harder it is for energy to move through it.
Okay, very good. And also the higher the frequency, so maybe we see that like high frequency has more energy and so it's able to travel further than low frequency. We'll explore that too. Go ahead, Mike.
Well, it's kind of odd since lower frequency you can see it more spaced out, so
Yeah.
you'd think it would go a further different distance.
Maybe. I don't know. We'll see. Okay, and then sound waves. We've talked a lot about sound waves. They're a different type of wave. They travel through air. You know, the molecules in the air. But they behave. They have similar characteristics as water waves and other waves too. Okay. Okay. So we talked about moving from problems to potential solutions. So we were talking. Well, so one of the biggest reasons we are negatively impacting the Earth is to get energy we need for our daily activities. What if we could get the energy from other sources that are less damaging and more sustainable, such as waves? Okay, so let's explore this idea. Okay, so we're going to use the bins that are on your table to demonstrate this. I want you guys to kind of play with waves. Try to hold on before you do that. Now, this is not like I do not want people to get wet. Splashing people with water. I want the water to stay in the bin. There should be no water on your table. So when you drop these things to make waves,
The bottom of our bucket's wet, so if we move the bucket, there's straight water.
that's all right. Yeah. Okay, so just be careful when doing this. Okay. And see how. Hold on, guys. I'm not done giving you instructions. Hold on for a second. So you wanna kind of play with these things and try to observe like amplitude, wavelength, and frequency. See if you can do different things to kind of get different results here. Okay. So I want you to make those observations. Again, I don't want you to get wet. One experiment that I do want you to do is listen close here. So I want you to take the styrofoam ball and put it kind of like, you know, off center in the bucket, and then I want you to drop the marble, see how it affects the styrofoam ball, and then drop the tennis ball and see how it affects the styrofoam ball. Okay, so start off with that experiment. Guys, just a few more things before we get started. So I'm going to pass out your packet. You guys have questions relating to this activity? So I'm going to pass out the packet and make sure you do that experiment and then answer these questions. Okay?
Is anybody there?
Mr. Richard? You have a towel?
I have paper towels and one hand towel.
Okay, good. You'll need them.
Did you see that? Do it. Nothing. Missing.
Higher. Yes.
Do it. Do it. Chromebooks. It's like no reaction.
Wait, what?
What are you doing? What are you doing?
We're trying to do
Sound wave.
Wait, water wave, I mean?
Yeah.
When they give me a bucket of water, I'm eventually gonna see one somewhere.
That looks like what, a B2D2 with some Star Wars, a little orange robot. What's it called? B2D2? What's it called? B8? Oh, BB8, yeah. So I don't so B2D2.
Like you're BB-8.
I don't know. There's like two of them, so.
It's not? I thought it was Friday, but we're watching on Saturday.
Yeah, I'm gonna watch it.
We're watching on Saturday.
It looks so good.
She's watching on Thursday. My cousin works at Steel She can always give me free tickets.
That's so cool.
I know, that's literally.
I got like 1 day early tickets, so I'm gonna like see it the night before it comes out. With my what does anyone have tickets for? Pretty lit. So.
It's Mickey Mouse. She has like 50% off on food, so she can always just buy me.
That's so cool. I wish I had that. So you didn't have to pay $20 for freaking popcorn and soda.
And the food isn't even that good.
And their candy, oh, it's $5.99. I don't even know how much it is. That's how I envisioned it. It's $5.99.
It's like so much right around.
Why am I spending $10 on popcorn? It costs them like $1 to make. I don't think there's a camera. No, not a camera. I don't want to get away.
Are you recording?
Oh, no.
It's
gonna record us. I just don't want to get away. How?
Mr. Richards. What are we doing? Have you been listening? Just testing things, I guess.
I have no idea what all I heard was electromagnetic. No one said electromagnetic waves and it was pissing me off. It was like, is someone gonna say electro? I'm not gonna say it, but is someone gonna say it?
Here you go. I went like around and missed you guys. Sorry.
Packet? No.
I'll edit it.
Matthew, here, now, here, right in front of
Don't touch the water. Don't let it touch the water. What if we just put a bunch of paper towels around it? That wouldn't help because the paper towels would get wet. It would help a little. A little. Wait. See, look, get the towel.
What does it sound like? Packet is asking. Can you splash it? Sounds like something hitting. Sounds like it's hitting the table, not even like. Yeah, I can like feel it vibrating the table.
You can?
No, that one. This one. Lock, like L-O-C-K.
Slightly wrong.
What? I think it's slightly wrong. No, it's fine. It's fine. It's fine. It's okay. I keep saying waves and not wave. Wait, that was a joke.
I smell slighty.
Slighty? I can't even read it because I'm that blind, so it doesn't matter. I don't think anyone else is.
Hey guys, down there on the floor. If I die, go back to your seats. Okay guys, attention up here. So let's discuss this. Okay, let's read what you guys kind of put up here. Okay, so water that moves. Okay, that's a great start. Let's build on that.
That's the best definition.
Alright, guys, I need everybody's attention up here on the board. You can use this to fill out the corresponding chart that you have in your packet. Okay. Hopefully as we're going through class, if you do the activities in class, you can fill out your packet. You won't have to do that for homework. So do that. It's best. Okay, so definition of wave, water that moves. We can do a little bit better. Okay, here we have a chain reaction of energy in matter. Okay, so chain reaction of energy in matter. So we have the energy is being passed on to the different molecules in the water, or the different matter. Okay, the sudden movement of a type of energy is a wave. Okay, that could be part of it. Before we go to that one, let's look at some characteristics of waves that you guys observe. So, additional force makes the total energy of a wave greater. Okay? So, you may have, who wrote this one? Don't be shy. It's a good one. Okay, you wrote that one. So what did you know, what made you come to that conclusion?
Throwing the styrofoam one like I was serving it.
Okay, okay, so you applied additional force to the styrofoam ball, which initially didn't make a very big wave, but as you applied more force, more energy, it created a larger wave, right? Larger how?
More water was displaced.
Okay, let's use our terms. So we have, did it make the wavelength greater?
Wavelength and
Did it make the amplitude greater, or did it make the frequency greater?
all of the above.
All of the above. Okay, maybe. So probably, definitely your amplitude. Probably, maybe your wavelength. Okay. And probably not your frequency. Because it's just one impact, right? Okay. Okay. So the diameter around the point of which water was touched. Okay, so we saw that the waves, the way they moved was they moved away from the source of impact or the source of the disturbance, right? The greater density in turn, usually mass results in a larger release of energy. So maybe you guys noticed that proportionally, you know, we had the marble, but the marble was like a lot denser, even though it was smaller, and it still created, you know, waves that you could see, or maybe waves that were larger than like the styrofoam ball, because it has more mass. So because it has more mass, it can transfer more energy. Or because it has more mass, when you drop it, it has more kinetic energy than like the styrofoam ball does, and so it can make larger waves. Okay. The amount of force within the object entering the water changes the wave size. Small force equals small waves, large force equals large waves. Great. Waves travel easier. What does that say? Waves travel easier through less viscous objects. Okay, so viscosity is the resistance of liquids to flow. So if an object is really viscous, like syrup or something, it's harder for the energy to to move through that substance. And so if you have, less viscous objects like water, that's an interesting observation. Good. Less surface area creates weaker waves with more amplitude, high frequencies. Less surface area. Somebody explain that one for me. What is the surface area? Go ahead.
So, like when I drop the marble in the water, that has less surface area when it impacts the water.
Oh, okay, so the surface area of the object that you drop. Okay, so not only does weight have an effect, or the mass of objects, but also how large they are, how much water they displace by their size.
Or if it's not something being dropped in, like the area where the force is dispersed.
Okay, so if you're just moving the objects around, the larger objects, the objects with the larger surface area, create larger waves. Interesting. I was thinking, when I saw surface area, I thought like the surface area of the water. You're talking about the surface area of the object. Very good. Okay, the waves / ripples are generated from the origin of the impact in every direction. Mass, surface area, and force have an important effect on the size of the wave / ripple. Very good. That kind of is all encompassing. Good. Okay, and then this was a really good definition of a wave, I thought. So wave involves the transportation of energy without the transportation of matter. In other words, a wave can be described as a vibration or disturbance that transports energy from one location to another. A straightly curly lock of hair. I'm not sure what this curly hair has to do. Explain the curly hair thing.
It was a joke.
It was a joke?
No, explain the
Because
joke.
wave, like curly, like wavy hair.
Oh, wavy hair. Dude, that's a lot of the guys didn't get the joke. I didn't get the joke. It's a hair joke, guys. Wait. I didn't get it. Okay, that's good. So I like the first part. So what we observe, so in that experiment that I asked you to do where you put the styrofoam ball in and then drop, create waves around it, if you notice, the styrofoam ball just didn't get pushed by one of the waves and get pushed all the way to the outside of the container. It like bobbed up and down. And the reason why it bobbed up and down is because the wave, is transferring energy to the different molecules. And so it's not actually, the molecules aren't actually traveling to the edge of the basin. So let's draw this for like a visual representation. Get a thing that works. So if we have our basin here, and we have, let's see, we have a wave like that, okay? And let's say we dropped, let's say our styrofoam ball is here, and just for funsies, we dropped the marble right here, okay? And so we created this wave here, and so what happens is we have energy. We're just going to do like a star here to represent energy, and we have molecules, and I'm just doing the surface water molecules here, but really we have molecules throughout the entire thing, right? And so just like you're saying up here, it creates a chain reaction of energy. And so we drop it, and it passes the energy on to the molecules next to it. And so when it gets to the styrofoam ball, it lifts, that styrofoam ball just moves because it's on top of, these molecules right here. And as they go up and down, they move the ball up and down, but they don't move it, they don't move it this way. It just moves, up and down. Okay, not that way. Okay, does that make sense why that happens? So, interesting story. Over break, I was canoeing on Lake Folsom.
Oh, yeah.
Yeah, it was fun. It was great. There was a lot of waves. It was really windy. And this boat went by. Like, I think he was kind of like laughing at me, like, oh, this guy's in a canoe, I'm in a motorboat. And he came like really close to us. Nah, I mean,
Did you
close.
boat with the
No, he was in a speedboat. I was in a canoe. I couldn't catch him.
No, you when you hit him with the paddle.
Oh, anyway, he wasn't that close. He was probably.
You throw the paddle.
Okay, let me finish my story.
Sorry.
He was pretty close. Okay, so what happened is he generated these waves, and so we're paddling, and then all of a sudden we're like going up 5 feet and then down 5 feet, and it was like I was like, oh man, we better not flip. We didn't flip, but it was kind of, at first it was scary because we were like bouncing these waves, and then it was kind of fun because we were like, oh, we're not going to tip. But what was happening is we didn't get like pushed over, we didn't tip because the energy was just pushing us up and down, not over. And so we just kind of bobbed up and down with the waves. We weren't like flipped over because the energy was just moving through the water. Go ahead.
One time, my aunt and uncle was anchored out with them on their yacht, and they had a bunch of their other friends who had their boats with them. And so we were anchored out, and we're kind of all connected, and so we have like the buoys on the side so that way they don't knock into each other.
Oh yeah.
A guy wasn't paying attention, and he blasted by in his speedboats, and all of them started crashing together.
Oh no.
And then one of my aunt's friends came out with like a megaphone and started yelling at him for doing that.
Yeah. Did it cause any damage to the boats?
No, but they were tipping. Everyone had to go to the side of the boats, and they were pushing against them so they didn't hit the windows or they didn't hit anything else.
Oh,
So the
geez.
cops, they were trying to come
Yeah.
together.
Interesting. So, I mean, in that circumstance, we have like, energy is also being, transferred into the boats or into the ball or into the canoe and causing it to move. Go ahead, Brian.
The wave would come into move the canoe like upwards, but it wasn't enough to the whole.
Yep. So it was the energy. Well, not that. It probably was strong enough to push the canoe over, but just because of the way that waves work, because they pass energy through the molecules. just because of the way that works, we just moved up and down, not flipping over. Go ahead, Mike.
This reminds me of my experience in Palos. We went to the ocean we could swim at where the waves were 5 feet instead of 10 feet.
Yeah.
And you just went up and down, but it's kind of funny because when you get kind of close to the shore, where the waves not break but are getting close to the shore, they kind of pull you closer to the shore.
When you get closer to the shore, the waves pull you closer to the shore?
No, because say if I was standing, maybe, since the waves broke close, once they break, you get pulled in and pulled out.
Oh.
Yeah, that's what I was talking about, sorry.
Yeah. Yeah, so when, let's see. Yeah, it's kind of different when waves break against the shore.
Yeah.
Why is that different? So don't waves break because you have water that's coming like down the beach and over, and so it kind of creates like that flipping motion.
And then that keeps happening. The water coming back pulls you back, and then when the wave breaks, it pulls you forward. So it's kind of a fun dynamic going round and round.
Yeah, and that's a more complex. I mean, yeah, the way that waves work. I mean, this is in general, like these waves are different than like waves breaking against a shore. There's kind of more involved in waves breaking on like a beach than just waves like these rolling waves like through the ocean. But yeah, okay, any questions? We've got a few minutes left. Any questions on characteristics of waves or the definition of a wave? Any questions that I can answer? No? No questions? Okay, guys, thank you for your participation in class today, and it's good to be back. We've got a month. Let's finish strong. You want to do the wave? Done. Here we go.